Good afternoon, everyone. Good afternoon. Okay, I think we are sitting for a while. Let's raise your hand like this. I think we are sitting for a while. I think we need a little bit of a blood flow going through. I know few guys are still waiting for, now it feels good, right? Great, okay. I would like to start this session by thanking you all taking out your time today. Time is a valuable asset, especially when we are dealing with threats. We are always into this constant battle of improving mean time to response, remediation, and recovery as well. My name is Tejas. I'm a security specialist. I work with the customer, help them operationalize security control. And today we will be diving deep into how do we scale security operations specific to the data protection at scale. So we'll be discussing about preventive controls, protection controls, and how do we implement the detection controls that can help us scale remediation and response both. So security is a job zero at AWS. It's one of our core central pillar for whatever we do, whatever service we develop. There are more than 144 compliances today that customer can use, download it from AWS artifacts, and these controls can be used as a baseline for customers' overall compliance program. But we don't just stop there. There are more than 300 security controls which customer can use to enhance the security for services that they consume. And then there are specific services for network protection, infrastructure protection, and for the data security as well. So one of the core questions that customer most of the time ask that, how do I practically reduce the operational overhead on the security? There are plenty number of operations like vulnerability management, posture management, threat management need to be done. So I always remember this one case where I was discussing with the customer and we were developing a ransomware protection controls. So after creating this long list of controls, we identified that actually by just shifting from the EBS-backed external upload module, instead of that, if we can move to the S3 itself, we can take away the runtime for the malware. Because every malware or ransomware needs a CPU, memory, operating system, some level of runtime. And the moment when we move it to the S3 bucket, the detonation of the malware can be taken away. And this has actually reduced around 70% of the cost on the security control, but also the operations. So the technical debt is also reduced. And this is one of the very good example of how do we modernize the application and reduce the attack surface itself. Now, definitely those preventive controls are good. We wanted to prevent more of the attack surface to be created. And we'll be definitely diving deep into that. But we also need protection controls, network protection and data protection, which will help us protect against a threat, not just attack surface. We wanted to have the detection controls, which will help us improve the observability on the security. And last but not least, we wanted to have remediation and response control created in such a way that can help us scale our operation. So let's look at the first one, preventive controls. So in AWS there are more than 240 services. If you can categorize, some of these services fall inside the VPC. It means if you want to send the data to EBS, it has to go through the VPC traffic filtering. But when you are uploading to the S3, it's a direct API call. So the identity is a parameter for most of your service that you communicate. And that is the first thing that can be used to prevent a lot of attack surface. So with this in context, how do you see the day one and day two operations? So most of the customer who has implemented the security operations at scale, they have created the procedures, policies, and mapped that with the guardrails, and created the data perimeter. So for example, you can say, hey, have a policy at the organization level, not at the project level, and in this policy I will define that no one can access any object from any S3 bucket if they are not inside my organization. And if you provide that as a guardrail at the organization level, the misconfiguration can be prevented because no one can publish that bucket, no one can give the access to the bucket to the external account. Now this is just one of the example that is called RCP, Resource Control Policy. You can also apply SCPs, that is Service Control Policy, again at the organization level. And there are more than 600 plus security controls in Control Tower which can help you increase the security. But these are the day one. It means you do this once in a year, once in a 6 month, and then again you relook at it when you are revising your policies and procedures. But then there are also day two operations. Day two operations like least privilege operations. So if your instance is communicating with S3 bucket and you have given S3 full access, but it has always used a get object. How can we do the least privilege operation at scale? We are talking about thousands of IAM role, hundreds of human user who is interacting with cloud accounts, AWS accounts. We also wanted to make sure that this misconfiguration is reduced. In your CSPM, CNAP tools where you are seeing constant red dashboard, how can we reduce that? I'm talking about prevention. Many customers also use self-service portals. So you can use AWS Service Catalog to build your standardized processes. So your self-service catalog is doing the deployment as per the best practice, which is reducing the chance of misconfiguration and posture violation. But still, least privilege question remains there. How can we do it at scale? At AWS, we heard this feedback from customers, and recently in Reinforce, we have announced IAM Access Analyzer available as a central place for the observability. So now, with external identity, access monitoring, and unused permission, we are identifying human user and machine user, means IAM role and user. Both the permission we are analyzing and updating customer what are not being used. Customer can use the policy generator and validator to rapidly create new policies and apply it on not just IAM role, but also can apply it in S3 buckets as well. So the S3 access analyzer can be used to identify what are the objects, what are the bucket being utilized from where. There are other security best practice that customer always ask us, that the most important one, which I personally recommend, is to do a micro segmentation of the accounts based on the intent-driven architecture. So if you have a PCI DSS full compliant workload, make sure that the IAM role or the user or the network is not communicating to the dev queue or staging environment. Make sure you are not using the long-term credential, you are using always short-term credential from IAM role. For human user, never use an IAM user, but use identity center. So these are some of the preventive controls which can definitely reduce the attack surface, right? But again, this is attack surface, not a threat. Threat is real. Even though we apply all these best practices, there are always chance that there are different insider threat or external threat can be manifested, and we need to protect that. So protective controls falls under these two categories: network protection and data protection. So one of the frequent asks from the customer on the DLP perspective, data loss prevention, is that I wanted to make sure that the data is not going out of my organization. And if you see the construct of the network, which is a VPC, there are various different places where we can apply the security control. So for example, security group, right? Security group can do a L3, L4 level firewall. It's like a stateful firewall. But if you wanted to add a deny rule, you can use knuckles at the subnet level. You can also segregate your inbound and outbound traffic and get it inspected with intrusion prevention system, that is AWS network firewall. You can, when the traffic leaves the internet gateway, you can also front end it with the CloudFront, which is a protection at the edge. This is mainly for the inbound protection, and you can protect it with AWS WAF and Shield Advance. But now this is still just exfiltration side of our threat vector. What about other threats? So we need to protect the data by using encryption at transit, encryption at rest. So let's double click on that. So if you have an application and you are interacting with the application, this first communication over the internet need to be protected, and that's where a customer can use ACM, Certificate Manager, to apply the certificate at the load balancer, at the API gateway, and also your CloudFront. It will make sure your communication is encrypted in transit. Customer also gave us the feedback that end-to-end encryption still you don't support because you cannot export the certificate from ACM. Now we support that as well. So if you are regulatory, if you fall under any regulation and you need to do any end-to-end encryption, you can do that as well. For encryption at rest, you can use AWS KMS, Cloud HSM, or payment cryptography. If you need PCI 3DS compliant resource or application, then you can just use the SDK integrated to the application and use pin verified encryption. Now, next one is how do we protect it while processing? So we have multiple AWS services. They are interacting with each other. Every service needs authentication and authorization. So if a Lambda needs to communicate to S3, it needs authentication and authorization. The same way for the EC2, the same way for even the S3 bucket that needs to have protection. You need to provide specific policies to that. But if your identity is not falling under the AWS IAM umbrella, then you can always use Secrets Manager. Store your database credential, long-term keys, which are the third-party keys, in the Secrets Manager where you can easily rotate, and don't hard-code that. And the last but not least is the observability. So CloudTrail is a data plane, management events that is being logged continuously, whether it's a machine who is interacting or a human user. There are also the S3 access logs. There are also VPC flow log and many other log streams that need to be monitored. So in the detection control, one of the key challenge that customer used to ask us is that we have multiple different log streams, right? And we need to make sure these logs are enabled in all the account, in all the regions, for all the services, and we have to follow up with the service team if someone has not enabled these logs. And especially when we consume these logs, they go to multiple different teams and different tools, consume it, but eventually we are duplicating the data. We are copying this log on and on and on, and these logs are also creating a lot of integration problems, because the SIEM, the way it consumes the log needs a different format. The way the analytics team consume it is a different format and different tool. So that's where we introduced Amazon Security Lake. So Amazon Security Lake is a data lake that enables the log stream from the source. It's uninterrupted log stream. You don't have to enable any VPC flow log, CloudTrail log, AWS WAF log, or EKS audit log. These logs are enabled, collected from the downstream to the service account, and converted in OCSF format. It's open cybersecurity schema format. It also compresses this log up to 70% and stores it in S3 bucket. Now once it is in the bucket, then you can consume these logs either by an agent and using the Bedrock agents, or you can build a dashboard in QuickSight. You can also build a dashboard in OpenSearch if it's a SOC use case for SIEM, or you can build a playbook, automation playbook that uses do the incident response for end-to-end. Customers also ask us that it's good that you are storing all the logs, but can you provide us the findings, a risk-based finding with the correlation? So customer asks us to correlate the vulnerability, misconfiguration, and the threat data. So we have recently launched Security Hub in public preview. This is a new Security Hub that does the correlation of publicly exposed assets. It also correlates with the sensitive data. If the asset is publicly exposed and having a vulnerability and having a misconfiguration, and it's connecting to the sensitive data, like a PII information, it highlights it as a critical and helps customer to remediate that. Now, this is still at the detection level, more of a detection engineering. Still, we need to do this response and remediation aspect, and both are fundamentally different. Response is usually done on the threat. You identify the threat, it's malicious IP address, you enrich that IP address, and then you block the IP address or a URL, or you contain the particular instance. But the remediation is not the same. For remediation, you need to do a lot of collaboration. For example, if there is a vulnerability, you need to apply the patch. You have to collaborate with the developer and the DevOps, and then do the testing, and then you assure that, okay, it works, and then you release it to production. The same way, when you want to make a bucket private, you really assess the risk whether something in the production will go down or not, and for that you need collaboration. Now, since these both are fundamentally different, the process and operations are also different. So many customers now started adopting agentic security operations. So you can define those 20% of the operation which are repetitive in nature, but reduce your 80% of the day-to-day operations. Once those are defined, you can create Amazon Bedrock agents. You can apply the memory, which will hold the previous logs of the incident and the cases that the way you have managed it. In the long-term memory, you can use S3 vector store. For the short-term memory, it's available in agent core itself. You can give external tool for the enrichment like Abuse IPDB, Virus Total, which will make sure that if it's a response, then the response is done after the enrichment and approval. So with that, I would like to conclude this session by saying that there is no silver bullet for having security control for data protection, but it's a layered security approach. Start with creating the policies and procedure and map them with your guardrails. And then you move towards the identity access management operations like least privilege operations, dissect them to the day one and day two, and apply the security control that will help reduce your operational overhead and technical debt as well. So with that, I would like to thank you. I hope it was helpful for you, and yeah.